Hi, welcome to my video on the motion of a particle in a straight line, and this video is going to find the speed at time of c. Find the speed at t equals c, and speed is going to be defined as the absolute value of the derivative of the position function, which is s prime, or it's the derivative of the velocity. So s prime is velocity. Notice I have absolute value, and the absolute value symbol, two strokes like that, the absolute value is equal to, this is the official definition, x when x is greater than or equal to 0, and it's a negative x when x is less than 0. Just want to make sure. And so the absolute value is, speed is the absolute value. So it makes no difference if the velocity is positive or negative. If the going down or was going up, then the absolute value is always positive. So that means we have to get the derivative. So s prime derivative of 6t squared is 12t. Derivative of 4t is 4. Derivative of 1 is 0. And we want the speed at 2 seconds. So the s prime of 2 is 12 times 2 plus 4. 24 plus 4 is 28. And if this is, again, this is in meters m, and the speed is in seconds, so it's meters per second. Again, this is s prime is the velocity. So the velocity is 28, and I got to do the derivative of that. So this is the derivative of the velocity. So there's the velocity. So I got to do the derivative, the derivative, the derivative, and the derivative of 28 is a 28 because it's positive. Okay, let's do right here. Let's do s prime again, the derivative of the position curve. So we get a 3t cubed minus 8, and this is 0. And so we have to get the speed, and really this is, I better put speed here and put an equal sign. So that's speed. So that's how, better make sure that's the speed because it's off the absolute value. So there's the derivative. And now we want at 1 second. So we put 1 in. 1 squared minus 8. 1 squared is 1. 3 times 1 is 3 minus 8 is negative 5. So the velocity is meters per second. But the speed, make that a d, speed is the derivative of s prime t, and so the derivative is of that is the derivative of negative 5, which is 5. So the speed is 5 meters per second. It's the absolute value. So I worked out in terms of working out, there's the derivative. I found the derivative, which is the velocity at 1 second, and then the speed is the absolute value of that. So if you wanted to put down, you wanted to write it like this, you can. But again, the easier way is do the derivative of the position curve is 4t cubed minus 60t plus 8. And we want it at 3 seconds, so s prime of 3, 4 times 3 cubed minus 60 times 3 plus 8, and that's 27. 27 times 4, 4 sevens are 28, 108. That's 60 times 3 is 180 plus 8, so it's 180 and 116. So it looks like it's going to be a negative 64. And so it's a negative 64 meters per second. So the speed is the absolute value of the s of t, or the velocity. So that's negative 64. So the speed is 64 meters per second. Again, do the derivative, sub the 3 in, get the answer, and do the absolute value of it, and you get the velocity. That means it's at 3 seconds, it's the particles going down, but the speed is still 64 meters per second. And if you look, again, that brings us to the end of it. If you like my video, click the like button, click the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. The content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.